Hello, and welcome to a new episode of this JPAD Modeller tutorial series dedicated to the CAD Manager features. During this video, you will see which parameters you can manage to shape the external geometry of the engines according to your preferences. Be careful, the set of parameters that you control here adds to the basic ones that you can manage from the Nacelles and Powerplant tab of the Input Manager, thus allowing you to further improve your engine models in terms of details. Each engine can be managed separately, by selecting the one to be modified from the drop-down menu. For each engine, you have two possible approaches. You can generate it from an existing template, by selecting one of the available files brought to you directly by JPAD Modeller. Or you can generate it from scratch, by choosing between different primitives called load, which stands for level of detail. Dealing with the first approach, once you check the template box, you will be enabled to select template files from default folders. Depending on the engine type you have specified in the Nacelle and Powerplant tab of the Input Manager, you will be able to choose between different nacelle templates only, if the underlying engine is a turbofan, or between different blade templates too, if the selected engine is of the piston or turboprop type. For the latter, you can also specify the pitch angle of the blades. Keep in mind that the same template and the same value of the pitch angle will be replicated for all the blades of the propeller. The total number of generated blades will depend on the number you provided in the dedicated area of the Nacelle and Powerplant tab. With regards to the second approach, you can choose between 4 loads, each one characterized by a different set of input parameters and a different level of customization. Depending on the engine type specified in the Input Manager tab dedicated to Nacelles and Powerplant, different loads become available. For a piston or turboprop engine, only the generic simple nacelle load is supported, whereas for turbofan engines the whole set of loads offered by JPAD Modeller is available, including the turbofan simple, the turbofan ducted, and the turbofan detailed ones. Once you select a specific load for the engine, you can choose to automatically generate a new nacelle by means of the updated parameterization by checking the automatic generation box, or you can decide to manually fix it by unchecking the same box and by clicking on the Details button, next to the Custom Modeling text field. Remember, you need to have updated the whole aircraft structure, before being able to have access to the Details window of each engine. The generic simple nacelle load is the simplest primitive available for each type of engine. This parameterization essentially relies on the main input quantities already provided in the Nacelles and Powerplant Input tab of the Input Manager, including the nacelle length, the inlet and outlet diameters, the maximum diameter, as well as its longitudinal position in the nacelle local reference frame. These characteristics are summarized for clarity at the top of the left scroll-down menu of this window and cannot be directly edited at this stage. In the Details window dedicated to this load, you will be able instead to modify the cross-sectional characteristics of these main sections, according to an approach similar to the one already presented in the Input Manager tutorial series for the parameterization of the fuselage cross-sections. By means of this approach and thanks to the possibility to assign different values for the parameters of the left and right sides, you will be able to design non-axial symmetric nacelles. In case you selected this type of load for the representation of the external shapes of the nacelle of a turboprop or piston engine, this will be automatically coupled with the propeller disc and hub, conveniently scaled and shaped according to the characteristics provided in the Input Manager tab in terms of propeller and inlet section diameters. The turbofan simple nacelle load is the simplest primitive for turbofan engines. Like the previous one, this load mainly relies on the set of input parameters for the engine geometry already specified in the Input Manager at the Nacelles and Powerplant tab. These are reported in the Turbofan Simple Details window, as uneditable fields in the left scroll-down menu. In addition, it gives you the possibility to further model the rear part of the engine, by including additional parameters related to the modeling of the end section of the bypass duct, of the final section of the core duct, and to the modeling of the core nozzle. Such for the generic simple load, you are also given the possibility to model the cross-sectional characteristics of the engine, with no limitations in terms of engine axial symmetry. The turbofan ducted load allows you to easily model flow through turbofan engines, particularly suited for aerodynamic analyses with flight stream or with any CFD solver. In addition to the main sections already included in the nacelles and Powerplant Input Manager tab, you will be able to provide characteristics in terms of additional cross-section dimensions, as well as their longitudinal position in the local reference frame. These cross-sections, for example, will allow you to define the height and width of an internal intake section, as well as the diameter and longitudinal position of an internal control section. Each cross-section can be manipulated individually, by assigning characteristics in terms of lower to total height and position of Bezier curves control points, thus allowing to design non-axial symmetric nacelle bodies. If you decide to export these models into Flight Stream, you will be provided with the possibility to also add an internal, automatically shaped cylinder, allowing you to set outlet pressure conditions more easily. Finally, the Turbofan detailed load gives you the maximum flexibility in terms of modeling the external geometry of a turbofan engine. By means of this parameterization, you can manage all the main characteristics of the longitudinal cross-section of an unmixed flow turbofan. You will be enabled to define additional cross-sections, as well as to specify angles and tangency constraints, allowing you to customize even further the engine shapes according to your needs. For example, you can define the shape of the spinner of the fan, as well as the geometry of the core nozzle. You can precisely model the shape of the bypass duct, as well as the shape of the terminal part of the core duct, starting from the low-pressure turbine last stage. All these characteristics make this load the most suitable one when you want to carry out detailed CFD analyses concerning engine characteristics or including engine contribution. Let's see an example of engine customization. We will use the Turbofan detailed load for this application. First, let's suppose that we want to modify the characteristics of the fan spinner, bringing the length from 174 to 250 mm, and both the start and the end angle from 90 and 0 degrees, respectively, to 45 degrees. Then we modify the fun duct length, bringing it from 474 mm to 525 mm. Then, we can update the overall length, which comprises the core duct nozzle, bringing it from 3.423 meters to 3.55 meters. Finally, we can modify the inlet angle, bringing it from 0 degrees to a value equal to 5 degrees. We can then press the update button and see the effect of these modifications on the geometry of the engine. The 2D plot in the bottom right corner, in particular, gives you a direct and clear impression of the impact of these modifications on the longitudinal cross-section of the engine. Once you are satisfied with the results, you can press the Save and Close button. Remember, you can only press this button and go back to the CAD Manager tab once you have updated the engine data structure. In order to see the modifications applied to one of the engines in the 3D view window of the 3D Explorer, you will have to click on the Update button in the top toolbar and select only CAD. Then, you will be able to modify the characteristics of another engine or to continue with geometry modifications in general. That's all for this video tutorial. In the next video, we will explore the content of the pylon section of the CAD Manager. See you there.